All right, question 2 on the practice test. Whatever, okay. So it says, what is the major product of the following reaction, abbreviated RxN? So here they give us a molecule, and it's being reacted with hydrogen bromide. So the mechanism, so I rewrote it. Here's CH2 double bonded to CH, which is double bonded to this tert-butyl group here. I rewrote it like this so we could see which carbon had the most hydrogens, because of we want to know Markovnikov's rule, which was in question 1. We went over that. So this is step 1. Alright, so we're adding hydrogen bromide. So the first step that's going to happen is the pi bond here is going to act like a nucleophile and give both of its electrons to hydrogen, which is acting like an electrophile. And this bond will break. Bromine will break off as an anion. So this is the slow step. So we're left with CH3. Notice that the H went here. Markovnikov's rule. The carbocation goes to the carbon that had the least number of hydrogens because it was the most substituted. This is unsubstituted. Or what is it? First degree. This is first degree. It's only attached to 1 carbon. This carbon is attached to 2 carbons, so it's more substituted. So it's a better. It's a more stable carbocation. So plus the tert-butyl group here, plus the bromine anion, right? Now, in this one, what we had to look at, there was an intermediate step, and that was a methanide shift step. So what happens if you have a secondary carbocation and it's next to a 3rd degree carbon, a carbon that's attached to 3 other carbons, or I guess this is a 4th degree carbon maybe. You see this arrangement where you have a 2nd degree carbocation and it's right next door to a carbon that's attached to 3 other carbons, so it's actually attached to 4, you're very likely to get something called a methanide shift, where the methane group from this carbon will come over and attach itself to this carbon, and the positive charge will move to this carbon right here, because this carbon, when this methyl group leaves, and the positive charge is here, this carbon will be attached to 1, 2, 3 carbons, so it will be a 3rd degree carbocation, which is more stable than the 2nd degree carbocation, right? So you got, okay, CH3. So we're going to get the methanide shift, right? This methyl group is going to shift over here. And then what we're going to be left with is the new molecule. This carbon now gained a methyl group. This has its hydrogen. This carbon lost a methyl group. It only has 2, but it's attached to three carbons, so it's a third-degree carbon. It's a third-degree carbocation. So this third-degree carbocation is more stable than this second-degree carbocation, right? Than the second-degree carbocation we have over here. So that's why that happened. So now finally we can go on to the final step. So here we have our molecule. Right, hopefully, yeah, you can see. And then remember we had our negative, we had our bromine anion. Now this is a trigonal planar carbocation. It's flat, so the bromine can attack from any side. The question is it going to create enantiomers or not? Is it going to create one molecule or 2? So I look at it, this carbon is attached to a methyl group. I already know that it's not going to form enantiomers because it's attached to 2 groups that are the same. It needs to be attached to 4 different groups in order to create enantiomers, so that's just not going to happen. We're only going to get one molecule. This is the fast step, right? And we get this molecule right here. And on the practice test, that is answer D.